Okay, today we are going to do the lesson 1.6, part 1. This is performing operations with complex numbers. To begin with, just so you know, a complex number is also known as an imaginary number. You'll hear me refer to it as imaginary quite often. Up to this point, you have been dealing with all real numbers. You've heard that many times in class for answers as far as domain or range, things like that. Now this is going to be the first time that you're going to deal with imaginary numbers. So you have had real numbers, and you are going to now have imaginary numbers. Right. For example 1, we're going to solve a quadratic equation. This is going to look very familiar to what you did in 1.5, solving for square roots, because you have a squared term, and that's the only thing you have as far as a variable goes. So that means that you can solve this by finding the square root. So go ahead and you're going to work this out the same way you did in 1.5. So 2x squared plus 11 equals negative 37. You're going to subtract 11 from both sides. Okay, that's going to give you 2x squared equals negative 48. You're going to divide both sides by 2. And x squared is going to equal negative 24. Now, at this point, you should be familiar with how to do this. Up to this point, you've done it before. Now, the next thing you're going to do is you're going to take the square root of both sides. You've done that. The only problem is now when you take the square root of both sides, it's going to be x equals the positive negative square root of negative 24. However, think about it. Is it possible to take two numbers and multiply them together, the two same identical numbers, and multiply them together and get a negative number? Can you do negative 2 times negative 2 and get negative 4? No, because a negative times a negative is a positive. So when you see something like the square root of negative 4, it's not 2. It's not positive or negative 2, because 2 times 2 is 4 and negative 2 times negative 2 is positive 4. So this, up to this point, is not possible. It's not factorable, cannot be simplified. Well, that's going to change now. Now, this little negative right here, take it out of your radical. But when it comes out of your radical, it turns into an I, and that I guess I would say probably stands for the imaginary. So the next step on this problem would be plus or minus I square root of 24. So if you notice, all I did was took this negative out and put it out front, but it turns into an I. It's like that whole Clark Kent and Superman thing. Inside the radical, it's a negative. Outside of the radical, it's an I. Then you're going to proceed and do the same process that you did in 1.5. You want to break your radical down, simplify your radical if you can. So how do you do that? Take two numbers, multiply them together. That would give you 24. So 2 and 12. 2 is prime, 12 is not. So I'm going to break 12 down to 2 and 6. And then 2 and 3. I have a pair of 2's. So remember from the on 1.5 that when you have a pair of something and you circle it, it counts as 1. So this pair gets to come out of the radical, but it only counts as 1, 2. But remember, you already have this out here. So outside the radical is plus or minus 2i. And then what's left, not circled, is 2 times 3. So inside the radical is 6. And that, ladies and gentlemen, is your final answer. Okay? That's actually probably one of the harder ones you're going to have to worry about. So let's go ahead to A. This one's actually a little bit easier, won't hurt your head quite as much. You already have an x squared equals negative 13. So what you're going to do is you're going to take the square root of both sides. So at this point you have x equals the square root of negative 13. So let's take that negative and take it out of the radical. But remember, anytime you have a radical, it's positive or negative I square root of 13. Remember, that negative comes out and turns into an I. Now, 13, you have to check to see if it can be broken down. But I happen to know that 13 is a prime number, and I know it can't be simplified anymore. So that's actually my final answer. Okay, this one over here, the next one, x squared by itself. So you're going to subtract 11. So you're going to have x squared equals negative 8. Find the square root, take the square root of both sides. So now you're going to have x equals the square root of negative 8. Take the negative out. When it comes out of the radical, it becomes an I, but remember radicals have a positive or negative answer. Square root of 8 Now, question yourself, can 8 be simplified? So 2 times 4. 4 can break down to 2 and 2. Find your pairs. You have a pair of 2s. That pair gets to come out, but remember, it only counts as 1. The circle counts as 1. So outside the radical, you have positive or negative 2i. And inside the radical, you have the number here that you did not circle, so square root of 2. That's your final answer. Okay. This one's a little bit different. It actually has parentheses in it, but we learned in 1.5 that you can take the square root of the parentheses because this square is on the entire parentheses, so taking the square root of the parentheses will just eliminate the square. So the first thing you're going to do is you're going to divide by negative 5. That's going to leave you with n minus 3 all squared equals negative 2. Then you're going to take the square root of the entire parentheses. Because this square applies to everything in the parentheses, this square root applies to everything in the parentheses. So that leaves you with n minus 3 equals the square root of negative 2. Okay? We still have something over here we need to move, but my word of advice to you is going to be simplify this first before you do anything else. So n minus 3 equals, take that negative out, so you have plus or minus I square roots of 2. That can't be simplified, so that's as far as it goes. So then what we need to do is we need to add 3, and you're going to add 3, and n equals, okay. These are a radical and they are imaginary. This is just a 3. These cannot be combined with this. So to write this, you're going to write it in 3 plus or minus I square roots of 2. This is the imaginary part of your answer. This is the real part of your answer. You're going to see in just another minute or two how this affects and why this is in standard form and why we write it like that. So the final answer on this one is n equals 3 plus or minus I on the square root of 2. Okay, let's go ahead and try this on your own. The questions I gave you pretty much mirror almost what I did. So go ahead and hit the pause button and press play when you're ready. All right, we already have x squared equals negative 38. So you're going to square root both sides in order to eliminate that square. So you're going to get x equals the square root of negative 38. Your next step is go ahead and take this negative out. I square root of 38. Then you want to check to see if 38 can be broken down. Well, 38 becomes 2 and 19. 19 is prime and can't be broken down, so we don't have a pair of anything. So 38 is as simple as it's going to be. Okay, go on to number 2. Hit pause. All right, first thing you're going to do is you're going to add 8 to both sides. That is going to give you x squared equals negative 28. Take the square root of both sides. X equals the square root of negative 28. Remove that negative. When the negative comes out, it becomes an I. So you now have I on the square root of 28. Then you need to see if 28 can be broken down. Well, 28 can be made as 2 and 14. 2 can be broken down again to 2 and 7. We have a pair of 2's. It gets to come out, but remember it has to multiply by the I. This only counts as 1, so x equals 2i. And the 7 is all by itself and has to stay in the radical. So there you go. You're done there. Okay. And number 3, go ahead and hit pause. Hit play when you're ready. All right, want to get this x squared by itself, so you're going to undo the order of operations, so subtract 33 from both sides. 5x squared equals negative 30. You're going to divide both sides by 5. X squared is going to equal negative 6. You want to go ahead and take the square root of both sides. So you have x equals the square root of negative 6. Can't have a negative inside the radical, so you're going to take it out. And check to see if what's left under the radical can be broken down. And 6 just breaks down to 2 times 3, so it can't be simplified, so you leave it alone. And that's your answer. Okay, let's move on. Next page. I mentioned this just a second ago. The standard form of a complex number is a plus or minus bi. This is the real number in your problem, and this is the imaginary. It's just a formal way of saying, it's kind of like when you have a, multiplying 2 times a and you write 2a instead of a2, because you and I know that this is how it should be written. Because if anybody writes it like this, it looks kind of funny. Well, we know that because that's a standard form. That's how you've been taught since algebra started. So that's kind of like this. It's a plus bi. All it's saying is when you get an answer, the number that's all by itself, like just a regular old number, it actually goes in the front, plus or minus, and then you're going to have your imaginary part. All right, the next section that we're going to do here is just adding and subtracting complex numbers. It sounds really fancy, but I'm going to tell you right now, you already know how to do this. Because even though they have eyes and they're still considered imaginary, they're all the same rules as if it was just any other variable. So you basically are combining like terms here. Just a couple little mistakes that people fall into, so just be careful. You have 2 sets of parentheses. You look at that plus in the middle. So because you have a plus in the middle, the parentheses technically weren't necessary. So you could just say 8 minus I plus 5 plus 4i. Then what you want to do is you just want to combine like terms. Your 8 and your 5 go together, and 8 plus 5 is going to be 13. Then you move over here to your negative I plus 4i. That's just like saying negative a plus 4a. It's the same exact rules. So it becomes plus 3i. And it says up here, be sure to write your answer in standard form. Is this a plus bi? It sure is. So that's your final answer. So take a breath. Yeah, it's actually that easy. So a little bit of downtime here, you get to breathe a little bit. All right, we have a subtraction in the middle. This is where people make the most mistakes, guys, so I'm just pre-warning you. This subtraction sign in the middle has to be distributed through. So if I covered this up and I actually put like a -1 here, you would know that it was just a single simple distributive property problem, and you would do it. But for some reason, when we put a parentheses in front of it, you forget that. So what you want to do is make sure that when you distribute this through there, it goes to both of them. So 7 minus 6i is your first parentheses. Then you're going to do negative times 3, which is -3. Now this is where the mess up comes into play. Negative times a negative is a positive 6i. And then you're simply combining like terms. So 7 and -3 is 4. Negative 6i and positive 6i just cancel each other. So your answer is just 4. And then with this one, same situation, you have a negative right there, so make sure when you do it, you distribute it through. So you have 10 minus 6, and then negative times a positive 7i is negative 7i plus 4i. Combine like terms, here's this group, so that's going to give you 4, and then here's this group, and that's going to give you negative 3i. It's in standard form, a plus or minus bi. Okay. In this case, you don't have to do plus or minus because it results in a positive 3i or a positive 3i or a negative 3i, so you don't need that plus or minus. All right, there you go. Now, go ahead and work out the next problems if you want to. If you're not comfortable and you want to work them out, go ahead. Hit pause when you're ready. All right, I'm going to kind of cheat a little bit on this, and I'm actually going to put the answers up to start with just so you can see them. All right, so for the first one, it was just a simple addition problem. So you really didn't need the parentheses, so you would do 9 minus 6, which would have given you 3. And then negative I plus 7i is positive 6i, and that's your final answer. Okay, number 2, go ahead and do it. Hit pause. Okay, number 2, that was one of those ones with the negative, so make sure you distributed your negative through, so that would have given you 3 plus 7i minus 8 plus 2i. Combine your like terms, you would have gotten negative 5. 7i and 2i is 9i. Go ahead and do number 3. Watch your negatives on this one. All right, this one, it actually had 2 sets of negatives that needed to be distributed through. You needed to distribute this negative through as well as this negative through. So you had negative 4 minus 1 minus I minus 5 minus 9i. It's a mouthful. Combine like terms, you ended up with negative 10 minus 10i. All right, last part, and the good news is the last parts of the sections, once you get the idea behind this, it's really not that difficult. So the last section here is just identifying a point on a complex plane. You guys are used to x and y. Now we have real and imaginary. This is the real axis, this is in the imaginary axis. Good news is you read it the same way you read a normal coordinate plane, left or right first and up and down. So to get to this point, I would go left 2. Well, left, you guys know that, is negative 2. Then I'm going to go up 1, 2, 3. Guys, that's the imaginary. So even though I went up 3, it's 3i. So this doesn't get written as a ordered pair. It actually gets written in complex number form. So this would be negative 2 plus 3i. So what it's saying is you would go left, then up. Left 2 on the imaginary axis, and then up 3. I just messed that up. Left 2 on the real axis, and up 3 on the imaginary. So on the second one here, you're going to go right and down. So you're going to go right 2, which is positive 2, and down 2, but you're on the imaginary, so it would be negative 2i. So that would be 2 minus 2i. And then this one, you're just going down on the imaginary. So your real number is actually 0 because you're not going left or right. But you wouldn't go 0 minus 1i because in mathematics, 0 is not necessary and 1s aren't necessary. So the technical answer for this would just be negative I. So there's your answer. All right, make sure you bring these notes to class because you've got a worksheet to do, and hopefully you understood this. It seems like a pretty simple one. It is, hopefully, but if you have any questions, please, please, please make sure you ask me when you come to class.